For this exercise we're going to be looking at surds. The reason why is because surds crops up throughout the work in A level, and some of the skills you need to use in surds are transferable to other areas within the A level syllabus. Start off, we have that symbol which means and you need to understand it's the positive square root. So the positive square root of 8 is 2.828. But you must remember though that if you have an expression like x squared equals 8, then x will be equal to the positive and negative root of 8. But when you have that symbol, it only means the positive root. And we have some basic rules that we need to follow. For example, obviously, root 3 times root 3 is equal to 3. Root 3 plus root 3, this follows normal algebraic rules. You've got root 3 plus root 3, so we have 2 lots of root 3. This is obvious as that. Following from there, 2 root 3 plus 4 root 3 is obviously going to be 2 of them, and 4 of them is 6 root 3. And when we multiply, 2 root 3 times 4 root 3 gives us 2 times 4 gives us the value of 8. Root 3 times root 3 is 3. 8 times 3 gives us a final value of 24. And we look at some examples now. Usual practice, these are often A-level paper, so we have 4 brackets as you can see here, etc. We times the first bracket out by 4 root 7, negative 4 times 2 is 8 root 2, plus 3 times 2 root 7 is 3 2s is 6 root 7, plus 3 root 2. And like algebraic rules, we collect like terms. We've got 4 root 7 plus 6 root 7 gives us 10 root 7. Negative 8 root 2 plus 3 root 2 is negative 5 root 2. That one is now completed and finished. Now we simplify. Again, a word that crops up again and again on the papers. And we have 2 plus root 3 squared. So you simply write down the process of what you're going to do, the brackets. 2 times 2 gives us 4. 2 root 3 is 2 root 3. 3 root 3 times 2, again 2 root 3. Root 3 times root 3 is 3. Again, collecting like terms, 4 plus 4 root 3. Sorry, 4 plus 3 is 7, gives us a 7 there. And 2 root 3 plus 2 root 3 gives us 4 root 3. Again, collecting like terms. And that one's now finished. Again, following on from simplify, here we have root 2, root 3, root 2 plus 2 root 3. I've written out all the stages of the multiplication. Root 2, root 2, root 2 times 2, root 3, root 3 times root 2, and root 3 times 2, root 3 from there. Root 2 is obviously 2. 2 root 2 times root 3, this is an important result. Root 2 times root 3 is root 6. As you can see, you can combine those within the root. Same over here, root 3 times root 2 is root 6. Going to time with this one. And here we've got root 3 times 2 root 3 is 2 times 3 is there. Again, we collect like terms. So we've got 2. 2 root 6 plus root 6 gives us 3 root 6. And 2 3s are 6. Final collection of like terms. We have 8 from the 2 plus 6, 3 root 6. And as I said before, notice that root 2 times root 3 is the same as root 2 times 3, is root 6. From this we could also go, root 20 is root 4 times 5, choosing that because we know if we split root 4 and root 5, we know the root 4 is 2. So from root 20 we can end up with 2 root 5. Similarly with root 72, splitting that into root 9 times root 8, root 9, and I'll split the root 8 into root 4 times root 2. Root 9 is 3, root 4 is 2, gives us 3 times 2 is 6, root 2. Completed. The next piece of work with surds is when they talk about rationalise the denominator. It means that if you have this value here, you do not leave a root underneath where the denominator is. And to remove the root 3, the simple process is to times top and bottom by both root 3, which gives us 5 times root 3, and underneath root 3 times root 3 is 3. And that question is now done, because we have rationalised that denominator. Next one, slightly more complex. We have 4 plus root 3 over 3 plus root 3. Now, if we need to rationalise that, then we use the concept of the difference of two squares. Because we know that if we times 3 plus root 3 by 3 minus root 3, we're going to resolve that there, which is what I've written down as the stage here. So we have 4 plus root 3, 3 plus root 3 times, as I said, 3 minus root 3, 3 minus root 3. And the working for that, as we times it through, we have 4 times 3 is 12, 4 times negative root 3 times 3, and root 3 times negative root 3. Remember, positive, negative, because there's a negative there. Root 3 is 3. Underneath we have 3 times 3 is 9, 3 times negative root 3 times 3, and root 3 times negative root 3. Which rationalises on the top. We see we have 12, minus 3 is 9, and here we've got negative 4 root 3, positive 3 root 3 gives us root 3. Underneath, obviously, these two go, which is why we chose that process of the difference of two squares. Underneath, we're left with 9 minus 3 is 6. And that we can rationalise slightly more to 9 over 6 is 1.5 minus root 3 over 6, or 1 over 6 root 3. Further example. Again, we need to rationalise it, so we know ahead we're going to multiply the top and bottom by 1 minus root 3, which is what I've written out here for the stages to do. So we go through that multiplication, and we have 2 times 1 is 2, 2 times minus root 3 times 1, and minus root 3 times minus root 3. Again, minus times minus gives us a positive root 3. Underneath we're going to have 1 minus root 3 plus root 3 minus 3. And again from there we can see the top line rationalises and simplifies down to 2 plus 3 is 5. And we've got negative 2 root 3, negative root 3, it's negative 3 root 3. And underneath, gone, as we'd expect, 1 minus 3 is negative 2. So we're then left with 5 over 2, and that's negative, and 3 over 2, as they're both negative, that'd be positive, root 3, which is minus 2.5 plus 1.5 root 3. If you prefer, you could take the half out, make it 3 over 3 root 3, negative 5. Okay, next one. This one looks more complex because we've got fractions, but it doesn't change the process at all. We just follow the same rules of difference of two squares. So to resolve this underneath, we need to multiply it by 1 over 2, positive 1 over 2 root 3, which is what I've written down for my steps there. So moving on. So we multiply out those values, and we have root 3 times a half, and root 3 times a half root 3. And obviously from the root 3 times root 3 gives us a value of 3 there. Underneath we're going to end up with a half times a half times a half root 3, negative a half root 3 times a half, and negative half root 3 times positive half root 3. Everywhere you get half times a half is obviously a quarter, and everywhere you get root 3 times root 3, you end up with 3. And we resolve that line, and we have on the top we have a half root 3 plus half of 3 is 1.5. And underneath we're going to have a quarter there and minus 3/4 there. That and that have now obviously gone. But if we look at this line here, I've worked it across here because it's quite small in space. That line stays the same. Here underneath we have a quarter minus 3/4 from earlier working. That is minus a half. To resolve the halves, the easiest solution is to times top and bottom by 2. That gives us root 3 plus 3 from doubling that, and underneath -1 by doubling that, which gives us root 3 plus 3 over -1, which, if we resolve the minus underneath, gives us minus 3 minus root 3. And work from examination papers. Expand and simplify. We've seen those words lots of times. Again, it's a matter of multiplying out the brackets here. So we have 7 times 5 is 35, as you'll see, we follow that down through. 7 times minus root 2, written out in the steps here. Root 3 root 2 times 5 is here, and 3 root 2 times -2 root 2 is there. So 7 5 is 35, 7 2 is a 14, root 2, negative. 3 times 5 is 15, root 2 is positive, and 3 times 2 is 6, root 2 times root 2 is 2, and again that is negative. And if we resolve that line, we end up with 35 minus 14 root 2 plus 15 root 2 is plus 1 root 2, and minus 6 times 2 is minus 12. 35 minus 12 gives us 23, plus 2 root 2, finished. Next question to simplify. Root 54 plus 12 over root 6. From the earlier working, we can split root 54 into root 9 times 6. I'm working ahead on that because I know the root of 9. And 12 are splitting into 2 times 6 as factors. Root 9 times root 6, well, we know root 9 is 3, so we can take that out. So that gives us, from there, gives us 3 root 6. And here, because I've written this 12 as 2 times 6 over root 6, root 6 goes into 6, root 6. So from there, we end up with 3 root 6 plus 2 root 6, which again, very simple, 5 root 6. Again, simple questions. We have 6 root 2 times 5 root 3 minus root 24. From here, 6 times 5 gives us 30, root 2, root 3 gives us root 6. Minus, and I split the 24 into root 4 times 6. Thinking ahead of root 6 here and having to have a root 6 here. So we have 30 root 6 minus root 4 times root 6. Well, root 4 is 2. So we end up with 30 root 6 minus 2 root 6, which gives us a simple value of 28 root 6. And now another version of the question that crops up. Again, when they ask you to express a particular function in a certain form. So we want to change this to a form of a plus b root 5. And it says a and b are integers. Again, very, very common question on the A-level paper. So first step, we have that squared, so let's do it. So we have this to square. So from this we end up with 2 times 2, 2 times negative 3 root 5, negative 3 root 5 times 2, and negative 3 root 5 times negative 3 root 5, which I've got over here. But you notice it's plus, because it's negative times negative is positive. And I've written the next line directly underneath so you can see where the steps come from. 2 times 2 gives us 4, 2 times 3 root 5 is negative 6 root 5, 3 times 2 is 6 root 5, again that's negative, and here we've got 3 root 5 times 3 root 5, 3 3 is a 9, root 5 is 5. And following down from that again, we have 4 minus 6 root 5 minus 6 root 5 is minus 12 root 5 plus 9 5 is 45. So we have 49 from the 4 plus 45 minus 12 root 5. And we had to express it in the form of a plus b to the 5, so that is a, b would be and minus 12 root 5. A is 49, B is negative 12. And finally we have, again, simplify 5 root 8 plus 4 root 50, and we've got to express this in the form of A root B. So we have 5 root 8 plus 4 root 50, splitting the root 8 into root 4 times 2, and splitting the 50 into root 25 plus times 2. Thinking ahead, so we've got a common root in both the parts of the equation there. So we have 4 root 2, we know root of 4 is 2, so it's 5 2s are 10, root 2, plus, we know that root of 25 is 5, so that's 4 times 5 is 20, root 2. So we have 10 root 2 plus 20 root 2 gives us a value of 30 root 2. So when it says A root B, A will be a value of 30 and B will be a value of 2. And last one here, express root 3 over 6 minus root 3 in the form of, again, P plus Q root 3. Very, very common, they ask you to do this type of working. It says P and Q are rational. Notice it doesn't say integer, so we can expect a fractional answer for this. So again, to resolve this and to remove this underneath, times the top and the bottom by 6 plus root 3, working again difference of 2 squares. So we have that over that from here, times 6 plus root 3 over 6 plus root 3. So we times this through, so we got 6 root 3 plus root 3 is 3. Underneath, working difference of 2 squares, we know how we're going with this now. That'll be 6 squared negative root 3 squared. This goes as 36 minus 3. And so from that we have 6 root 3 plus 3 over 36 minus 3 is 33. And because I want it in the form of P plus Q to root 3, we can have the numerical value first and the surd afterwards. So we're going to have 3 over 33 and 6 root 3 over 33 separate. 3 over 33 is 1 over 11, and 6 over 33 comes to 2 over 11 root 3. So from that, when I said P plus Q root 3, P will be 1 over 11 and Q will be 2 over 11. Finished.